Hello, mathematicians! Welcome to Unit 5, Lesson 4, Arithmetic Series. Do now problem, pause the video, see if you can answer this before I go over it. When a famous mathematician, Carl, was about 8 years old, he was insubordinate towards his teacher. The teacher punished the student by making him find the sum of the first 1,000 positive integers, natural numbers. How did this math genius do it without a calculator within 5 minutes? All right, so let's take a look. So what happened was he got in trouble. The teacher was pretty mad at him, and he punished him by saying, you're going to come up to school on the chalkboard. You're going to write the first 1,000 numbers, and then you're going to find the sum of those numbers. So what he did was he said, I'm not going to do that. That'll take too long. So then what he did was he started writing down the first couple of numbers. 1, 2, 3. And then he did ... and then 998, 999, and 1,000. He's like, there's got to be a quicker way to do this. I'm not just going to sit there and do 1 plus 2 plus 3 plus 4 plus 5 all the way to 1,000. It'll just take too long. So he saw a pattern. He saw that if you add the first number and the last number, that was 1,001. Then if you add the second number and the second to last number, that was also 1,001. So then he realized, all right, if there's 1,000 numbers, there'll be 500 pairs. And then they're all going to equal 1,001. So he took 500 and then he multiplied it by 1,001. All right, so 005,005. So the sum of the first 1,000 numbers, natural numbers, or the first 1,000 positive integers is 500,500. So then he said, you know what? I'm done. The teacher actually just left him by himself, and he thought he was going to take, a couple hours to do this. He only did this in about 5 minutes. So he did it on the board. He left it. So he circled it and said, this is the sum. See you tomorrow. And he walked away. That was the story of Carl Friedrich Gauss, famous mathematician. All right, so let's move on. Let's take a look at the definition of a series. Now, a series basically is just the sum, especially as an arithmetic series. Series means the sum of an arithmetic sequence. You want to find all of the numbers, okay, and you want to add them together. So that's what this is saying. If you have the first term, the second term, the third term, the fourth term, the fifth term, all the way up to the nth term that you want, you take all those terms and you add them together. So now number one looks like another problem that we've seen before, right? You should know what this is, right? We've definitely worked with this in full detail. A of n is equal to a, so n minus 1 plus 5. Right? So this looks like the previous term. So if I want the second term, I need the first term. If I want the fifth term, I need the fourth term. So given the arithmetic sequence defined by this recursive definition, we want to find S of 5 means the sum of the first 5 terms. Now we need the second term, the third term, the fourth term, the fifth term, because they have to give us the first term of the sequence, which they do. The first term of the sequence is 1. If I want the second term of the sequence, I need the first term, right? You're going to substitute -2 in, -2 plus 5, and so on. So you should be able to generate the first 5 terms of the sequence just from previous knowledge. So go ahead and pause the video and do that. So here are the first 5 terms of the sequence. Now we have the first term, which was given to us, which is a of 1. Right? As you can tell, here's a of 1. is -2. Now if I want the second term of the sequence, you take -2, you plug it in. -2 plus 5 is 3. Now if I want the third term of the sequence, you take 3, you plug it in. 3 plus 5 is 8. If I want the fourth term of the sequence, you take 8, you plug it in. 8 plus 5 is 13. And if I want the fifth term of the sequence, you plug 13, which is the previous term. 13 plus 5 is 18. Now, I don't just want to list out all the terms. I want to find the sum. This means find the sum. So you take the first term, second term, third term, fourth term, fifth term, add it all up. Probably do this in our head. -2 plus 3 is 1. 1 plus 8 is 9. 9 plus 13 is 22. 22 plus 18 is 40. So there you go. The sum is going to be 40. Just add them up, all the terms. That's what this is saying. This is from the summation notation. Take the first term, add it all up to the fifth term. So it's choice. It is choice 2. All right, this is what we just did with Gauss. If you want to add a set of numbers and it's an arithmetic sequence, you pretty much go in pairs. First term and the last term. Second term, second to last term. Third term, third to last term. It's going to add up to the same number. What does each of the paired off sums equal? 20. 3 plus 17. 5 plus 15. 7 plus 13. Why does it make sense that this sum is constant? Because if I add 2 and I subtract 2, that gives you the same values. That's what you can write for B. How many of these pairs are there? So if we have 1, 2, 3, 4, 5, 6, 7, 8 numbers in total and we have pairs, that's going to be half of that. So that's going to be 4 pairs. All right, so it's 4 pairs. Using your answers from A and C, find the value of the sum of the using a multiplicative process. So we just did that before. It's really the total number of pairs we have times what the first and the last, or the second and the last numbers add up to. So 20 times 4. So if you add up these numbers, that's going to give us 80. We just did it quickly. So you take the first term, you add it with the last term. Second term, second to last term. That should be equal. That should be the same value. You figure out the number of pairs you have, just multiply it by the number of pairs, and that will give you the formula, or the answer. Now the formula, generalize this now and create a formula for arithmetic series sum based only on its first term and its last term, and the number of terms. So if you have the number of terms, what did we do? We had 8 terms here. How did we get 4? How did we get 4 pairs? Take the number of terms n, divide it by 2, and then we added the first term plus the last term. And that's equal to the sum of all the terms. And that's the general formula. So if we have the number of terms, the first term and the last term, we can figure out the sum of any arithmetic sequence. All right, so there it is. We just went over that. There it is. Which of the following is the sum of the first 100 natural numbers? Show the process that leads to your choice. Now, I gave you that example with Gauss. If you want to do this just by understanding what's happening here, you don't need the formula. Right? 1, 2, 3, ... 98, 99, 100. What's the sum of the first and the last terms? 101. How many total pairs are you going to have? So if there are 100 numbers, how many pairs are you going to have? 50. So you can multiply 101, which is the sum of the first and the last, times the number of pairs you have. And that's what you do. That's how you find the sum of an arithmetic sequence. So it's going to be 0, 5, 0, 5. So 5,050. Now, if you want to use the formula, this is what I just did. I just showed, this is the formula. What this means is the sum of the first 100 terms of the sequence, number of terms divided by 2, and then the first plus the last. What I like to do is I like to divide first and then multiply. So 100 divided by 2 is 50, which is what we just did. And then the sum of the first and the last, which is 101. You multiply that and gives you 5,050. Exercise 4. Find the sum of each arithmetic series described or shown below. The sum of this 16 terms given by. Now, remember what you need to find the sum of a sequence. You need the first term, the last term, and the number of terms. We don't care about the common difference. We don't need that. We need the first term, the last term, and the number of terms. If you don't have either one of those, if you don't have all those, if you just have 2 of those, you need to find one. You need to find the missing number. You need the number of terms. This is what you need. Number of terms. You need the first term and you need the last term. This means the last term. So here's the last term, the first term, and the number of terms. I'm going to erase this in a second, so copy that down. That's what these mean. Okay, so do we have that? We have the first term, we have the last term, and we have the number of terms, 16 terms. So we're good. We can just jump right into the formula. So I'm going to erase this. So if you want, you can always pause it, go back and pause it. All right. So let's go ahead and jump right into the formula. There it is. I want the sum of all 16 terms, number of terms, first term plus the last term divided by 2. Like I told you, I like to do 16 divided by 2 is 8. Add the first term and the last term, which gives you 40. Multiply those, gives you 320. Okay. All right, now let's take a look at B. The first term is -8. The common difference is 6, and there are 20 terms. What don't we have? Remember what we need. We need the first term, the last term, and the number of terms. We have 20 terms, the number of terms. We have the first term. We do not have the last term. So you have to first find the last term, and once you have the last term, then you can use that sum formula to find the sum of the sequence. Watching the Islander game, it's tied 4-4, and they're in overtime. Looks like it's going to be a shootout. All right, let's get back to this. So what are we going to do to find the 20th term? We're going to use the formula. We're going to come up with the formula, and then we can plug in 20 for n. So there's your formula. Remember what we did? It's the common difference times one less term, the one less term that you want. So if I want the 20th term, it's 19. You put 19 because it's 21. 20 minus 1 is 19 because you're going to add the common difference, which in this case is 6. You're going to add that 19 times. So 19 times 6 plus the first term of the sequence, which is -8, and that will give us the 20th term. All right, so if you want the 20th term, 6 times 1 less than the term that you want, so that's 19 plus the first term of the sequence. So 6 times 19 minus 8, which gives you 114 minus 8, which is 106. So the 20th term of the sequence is 106. Now we have the last term, which is 106. We have the first term, which is -8. And we have the number of terms, which is 20, and then we can use our formula, 20, which is the number of terms, times the first term plus the last term, all over 2. Now, you guessed it, I would divide 20 and 2 first, which gives you 10, and then you multiply it by the sum of -8 and 106. So 10 times 98 gives you 980. All right, very good. All right, so that's your sum. So that's the final answer, 980. Let's see what we have with C. The last term is -29. The common difference is D. which is -3. So what we have, we don't have the first term. We have the number of terms. We have the last term. We don't have the first term. So how do you do that? So how do you find the first term? We go back to our trusty formula. Again, anytime, just pause the video, see if you can do it on your own, see if you can get the answer before I go over it. So always go back to the formula, because that, if you have two of the three, okay, you're going to need a formula to pretty much find that third piece that you're going to use to plug into the sum formula. So we have the last term, which is -29. It's going to go in for a of n. We have the common difference, which is -3. We don't have n. Actually, we do have n, which is the number of terms, which is 12, because we're going to have 12 total terms. But we just don't have a of 1. We don't have the first term of the sequence. So we're going to plug in -29 in for a of n. -3 goes in for d. Like I said, we had 12, which is n, and then we don't have a of 1. So simplify. We have -29 is equal to -3 times 11 plus a of 1. Multiply -3 and 11, which gives you -33. And then you bring the -33 over to the other side, add 33 to both sides. And the first term of the sequence is 4. So we have the first term of the sequence. We have the number of terms, which is 12, and we have the last term of the sequence, which is -29. So there you go. We can plug it right into the sum formula. 12, which is the number of terms. 4 is the first term. -29 is the last term. All divided by 2. So 12 divided by 2 is 6. 6 times the sum of 4 and -29, which is -25. And you multiply that, it gives you -50. So the sum of the first 12 terms of the sequence is -150. All right, D. Let's see what they give us. We have the first term, we have the last term, but we don't have the number of terms. They don't tell us how many terms there are. Now what you can do is you can realize, what's the common difference here? What is it going by? 5, 8, 11. It's going by 3. So you can keep on going. 11, 14, 17, 20, right? And you can keep on going until you get to 77. Just count the number of terms you have. That's one way of doing it. And then you have the number of terms, you have the first term, the last term. You can just jump right into the sum formula. But if you wanted to use that formula that we were just working with C, or even the previous problem and B, you can plug in what we have and find our missing variable. So in this case, we have a of n, which is 77. We have d, which is 3. We don't have n here, which is what we're trying to find, and we have the first term. And then you'd solve. Now, what I would do first, you could distribute the 3 if you want, but if you want to be smart, bring the 5 over first. Gives you 72 is equal to 3 times n minus 1. See how the 3 in the parentheses attached for multiplication? You can undo that. You can divide by 3 first, and you get 24 is equal to n minus 1. Bring the 1 over and gives you 25. So there are 25 terms. Now, like I said before, you could have done this by just keep on adding 3 and just do that throughout, and that gives you, and you just count how many terms you have. But using the formula is pretty smart. Algebraically, it's nice, it's quick. Now we have the number of terms. We have the first term and the last term. We can use that sum formula. Number of terms is 25. First term is 5. Last term is 77 divided by 2. Now since if I divide by 25, you're going to get a decimal. You don't really want to do that because 25 is not an even number. So I'm going to add 5 and 77 first. It gives you 82. Then I'm going to divide 82 in 2. Because 2 goes into 82 evenly and gives you 41. Multiply that to 25 and you have your answer. So the sum of the first 12 terms of the sequence is 1,025. All right, last question, number 5. Kurt has set up a college savings account for his son, Maxwell. Kurt deposits $100 per month in an account, increasing the amount he deposits by $10 per month each month, then how much will be in his account after 10 years? Now, when I first read this question, I thought it was just saying after each month, he's going to have $10 more than what he had previously. So like after the first month, he was going to have $110. And And then the second month he was going to have, or the first month he was going to have $10 more than what he had previously. So it was going to be 100, 110, 120, 130, 140. But it's actually, you're starting with 100. And then in the second month, he's going to have 110 more. So in total, he was going to have 210. And then in the third month, he was going to deposit 120. So in total, he was going to have 100 plus 110 plus 120. Okay, so I read it a couple times. You should read it a couple times. Any problem, you should read it a couple times. So this is what the problem is asking. This is the first month. This is how much more he's going to have the second month. This is how much more he's going to have in the third month. So now he's going to do this for 10 years. So how many months is that? So he's going to do it every month for 10 years. So how many months is he going to do this for? 10 times, because there's 12 months in a year, 10 times 12, which is 120. So he's going to do this for 120. So that means there's 120 terms. So this is the first term of the sequence, the second term, the third term. And he's going to keep on doing this. Now, we don't know how much money he's going to save in the 120th month. So we know the number of terms is 120. We know the common difference, right? What is it going by? It's going by 10. But we just don't know the last term of the sequence. Now, how are you going to find out if this is an arithmetic sequence? How are you going to find the last term of the sequence? Right, there's our formula. This will generate any term you want. So we have the common difference, we have the number of terms, and we have the first term of the sequence, which is 100. Let's put that in here. That's very important. So you're going to plug that information in here. So we want the 20th term of the sequence. Common difference is 10. It's going to be one less term that you want. So you want the 120th term. So one less than that is 119, plus the first term of the sequence. So the 20th term, which we just found out, is 1,290. So that's what he's going to save in the last month. So each time he's saving $10 more than previously what he's saving. So the first month he was saving $100. In the second month he's going to save $110. In the third month he's going to save $120. And then what we want to do is we want to know in total how much is he going to have in the account. So what that means is you're going to add everything up. You're going to add 100, 110, 120, 130, all the way up to 1,290. So how do you do that? Using the sum formula. So the sum formula of all, there it is, of all 120 terms is 120 times the first term plus the last term all over 2. All right, so like I said, I like to divide first. I'm going to divide 120 in 2 because 2 goes into 120 evenly, 60 times. And then 100 plus 1290 is 1390. So if you multiply that, so he is going to have, let's go back, sorry. He's going to have $83,400 in his account after 10 years, that is a pretty good amount. If you can do that, like I've been telling you the whole year so far, if you get a chance to save money, if you have money that you have in your hand, then you should try to put it away. Don't blow it. Don't go to Taco Bell at night. Don't, buy the latest, game because you want it. I understand that, instant gratification, you want it, you want to keep it, you want to go out and buy new things, new toys. But if you could save money in the long run, you'll be better off. All right, so anyway, hope you guys enjoyed this video and you're watching my videos. Have a good day.